Today we're talking about parallel and perpendicular lines. So you've probably seen these before, but just a reminder, parallel lines are two lines with the same slope, whereas perpendicular lines are two lines with the opposite reciprocal slope. All right, so here's a couple examples. If we look over here, this says y equals negative 2/3 x plus 4. So the slope in that equation is going to be negative 2/3. And if I look at this one's written in point slope form, and its slope, of course, is also negative 2/3. So those two lines are parallel. Whereas a perpendicular example, in this one, this is written in point slope form, and its slope, you can clearly see, is negative 4/7. And so if I want the opposite reciprocal, opposite means if one's positive, the other one's negative. Or if one's negative, the other one's positive, just opposite sign. And then reciprocal means if you have a numerator and denominator, those flip. And so you get the kind of reverse side of the fraction. So the 4's on top here, 4's on the bottom there, 7's on the bottom, and then the 7's on top. One's negative and one's positive. So those two lines are going to be perpendicular. Let's try some examples with those. All right, this says to write the equation of the line in point slope form that passes through 5, negative 8, and is parallel to y equals negative 3/5 x plus 8. So, all right, so point slope form, we need a point and we need a slope. Okay, I have the point, which is good. This is going to be my x1 and y1. And then the slope that I need, since this is parallel, it has to be the same slope to the line that I already have. And so the slope in this problem is negative 3/5. So if I kind of take what I have here, my point 5, negative 8, and my slope is going to be negative 3/5. I can go ahead then and write an equation using those two things that goes in point slope form. So I'm going to write out what the general form of point slope is. That's y minus y1 equals a slope times x minus x1. We're just going to insert these parts into this formula, and that'll be it. Okay, so let's try it here. We got y minus, my y1 is a negative 8. So y minus a negative 8 is y plus 8 equals a slope negative 3/5 times x minus the x1 that I have is 5. All right, and since they just want to end point slope, I think we're done. Let's try another one. More of a challenging one here. This says to write the equation of the line in point slope form that passes through negative 210, and this time it's perpendicular to this equation, 2x plus 5y equals negative 4. All right, so we're still doing point slope, and I have the point, but the slope is a little bit more challenging to find because we're written in standard form. So if I solve this for y, that'll probably give me the best way or the fastest way to get what the slope is. So let me move the 2x over. We're kind of taking this back to slope-intercept form, if you will. And now we have 5y equals negative 2x minus 4. Divide by negative 5, divide by negative 5. And really all you care about here is that since now the y is isolated, what number comes in front of your x? And that's going to be a negative 2/5, okay? You really don't even need the other stuff after that. You can if you want, but negative 2/5 is the current slope of this problem. But I don't want the same slope, that'd be parallel. I want the perpendicular slope. So instead of negative 2/5, I want positive 5/2. All right, so I'm going to say the slope that I want to work with is 5/2, right? The opposite reciprocal. Okay, and then I also have this point still, that's negative 210 from earlier in the problem. That's going to be my x1, y1, and now I can throw that into point slope form. All right, remember point slope form, y minus y1 equals a slope times x minus x1. Put those parts in, we have y minus 10, that's my y1. The slope that I want, right, this is the perpendicular slope, so this is the one I'm using, 5/2, times x minus the x1, x minus a negative 2 is x plus 2. Okay, so I think y minus 10 equals 5/2 times x plus 2 is the point slope version of that equation. All right, let's try some more. This time it says write the equation of a line in slope-intercept form that passes through 1, negative 2, and is perpendicular to x plus 3y equals 6. Okay, so kind of similar to the last one where we had x plus 3y equals 6. This is standard form. We want to solve for y to be able to find the slope here. Then we can figure out what would be perpendicular to that slope. Okay, so I'm going to solve this one for y. Subtract x to the other side first, giving us 3y equals negative x plus 6. Divide by 3. And again, you really don't care what comes after this. Just you want the negative 1/3. That is the current slope. If you want to say plus 2, you can. But that's the current slope of this problem. We don't want the same one, though. That would be parallel. We want perpendicular, so the opposite reciprocal. So I'm going to flip the 3 on top, 3/1, and make it positive. And of course, 3/1 is just equal to 3. So it's going to have a slope of 3 for the one that I want, as well as it's going to go through this point 1, negative 2. That would be my x1, y1. So just taking the parts out of this problem that they give me, I am given a point and a slope. So I'm going to start this out in point-slope form. However, I'm going to have to eventually switch it to be slope-intercept, which really isn't too terribly hard. So again, start with point-slope, y minus y1 equals the slope times x minus x1. Put the different parts in. We have y minus a negative 2 is y plus 2. The slope that I want is just 3. And then x minus the x1 is 1. Okay, so that is currently point-slope form. That's where we stopped in the last problem. But now to make this slope-intercept, I have to solve this for y. Remember, slope-intercept is y equals mx plus b. And so to do that, let's maybe distribute this 3 and eventually we'll move the 2 over. So y plus 2 still equals 3x minus 3. Subtract 2, y equals 3x minus 5. Okay, now that's written in slope-intercept form, so I think we are done. Last problem for this video says to write the equation of the line in standard form this time that passes through the point 5, negative 1 and is parallel to x plus 3y equals 6. Guys, never work harder than you have to. This was the exact same equation they gave us in the last problem. So remember that a slope that we found was negative 1/3. Now, last time they wanted perpendicular, this time they want parallel. So the slope I'm going to use, the parallel slope, if you will, is still negative 1/3. Okay, so that's what I'm using. The point that I want here is 5, negative 1. That'll be my x1, y1. Okay, so let's put this into point-slope form. Maybe pause the video, try it on your own here. I'm going to do it real quick for you. All right, now that it's written in point-slope form, we want to do a few things to get this into standard form, okay? Remember, standard form cannot have any fractions. I see that I have a fraction. So we want to get rid of that by multiplying the entire thing by the denominator of my fraction, which is 3. Excuse me. So we're going to have 3y, and then 3 times 1 is 3. And then 3 times negative 1/3. The whole reason we chose 3 is so that this can cancel and give us a negative 1. And then we're going to multiply that by the x minus 5. Notice I didn't multiply this 3 into this part here. This is all currently one term, the negative 1/3 times 3 minus 5. So you can only multiply that 3 into the beginning part, okay? All right, then from here we can distribute this 1. 3y plus 3 equals negative x plus 5. And then we need, after we have no fractions, now we need the x and y on the same side of our equal sign. So let me move the x term over by adding it. Okay, and that means we want only the x and y on that side. So I'm going to move this 3 to the other side by subtracting it. So those two things will cancel, giving me x plus 3y equals 2. Okay, and the last thing we have to check for is the x term positive? And it is, so I think we are done. And x plus 3y equals 2 is in standard form.